let's check it out. Number one, a musician has a new song available for downloading or streaming. The musician earns this much each time the song is downloaded, underline, and 0.002 each time the song is streamed. So we're probably just going to be matching up, dollar signs with variables. Which of the following expressions represents the amount in dollars that the musician earns if the song is downloaded D times and streamed S times? So the variables match with the word you think they would. So we're just writing it in. 0.09 for downloads plus how much they make for streams? 0.002 for streaming. That's really it. Choice C. Just matching up variables and numbers. That's all you got to do. Move on. We got to save time and get done with this test fast. All right. Quality control manager at a factory selects 7 light bulbs at random for inspection out of every 400. At this rate, how many light bulbs will be inspected if the factory produces 20,000? So this is a simple proportion, right? 7 inspected for every 400 produced. How many light bulbs will be inspected? We don't know. For every 20,000 produced, right? So I can just cross multiply. So 400x equals 7 times 2 is 14 with 4 zeros. Okay. Now we can get rid of some zeros here. Boom, boom. You can just use your calculator at this point. So what is 4 into 14? I don't have my calculator on me, so I'll just do it in my head real quick. X equals 4 into 14 is 3. 3. Well, it's not 300 exactly, so it's got to be 350. All right, 350, and we can check it, right? 350 times 4. 0, 20, 12, 14, yeah, 1400. Okay, that's it, 350. If you have a calculator, fine. You can do it like that too. Number 2 is B. All right, number 3, this one has an equation, and it says one end of a spring is attached to a ceiling. When an object of mass m kilograms is attached to the other end of the spring stretches to a length of L centimeters as shown in the equation above. All right, fine. What is m when L is 73? All right, so we're really just plugging in here. So L, I'll make sure I put it in the right spot. 73 equals 24 plus 3.5 m. Well, minus the 24, 9. So we've got, 49? Yeah, equals 3.5 m. Divide by 3.5, divide by 3.5. And you can just punch it into your calculator real quick if you got it. 49 divided by 3.5 gives you 14. All right, m equals 14. Move on. You're done. All right. Where's number 4 here? Let's go find number 4. Oh. Sorry, I'm going to have to move this sucker over. All right. The amount of money a performer earns is directly proportional to the number of people attending the performance. All right. The performer earns 120 at a performance where 8 people attend. Okay. How much money will the performer earn when 20 people attend the performance? Again, this is another, just set up a proportion question. So you could literally write 120 bucks for 8 people. How much is he making? We don't know. But when 20 people show up. So again, this is like the one we just did a couple of seconds ago. It's just 120 times 20 equals 8x. I can divide by 8, and if you want, you can do the whole thing in the calculator. Sorry, that's an 8 there. Right, so you can do 120 times 20 equals, divided by 8 equals, and you get 300. Done. Okay, so x equals 300. Let's move on. Let's see what the second part is. The performer uses 43% of the money earned to pay the costs involved in putting on each performance. The rest of the money earned is the performer's profit. What is the profit the performer makes at a performance where 8 people attend? Well, they gave us that information in the beginning, right? Let me just scroll back up. What was it? 8 people gets them 120 bucks. So there's 120 bucks that he's getting for the show. And they say the performer uses 43% of the money to pay the costs. So I'll multiply by 0.43. So 120 times 0.43. So 51.6 goes to costs. All right. The rest of the money earned is the performer's profit. All right, so we just got to subtract. So 120 he made originally, but 51.6 goes to costs. So what's left over is just profit, right? Whatever's left over. So 120 minus 51.6, 68.4, choice C, you're done. All right, 68.4. Another way you could have done it if you wanted to speed things up, I just realized you could have just taken 120. So 43% goes to costs. That means 57% is whatever's left over. So you could do 120 times 0.57, and what do you know? That also gives you 68.4. So that's another way to do it, kind of to speed things up. All right, number 6. Let's just get this stuff done. Okay. When 6 times the number x is added to 12, the result is 8. What number results when 2 times x is added to 7? All right, we just got to learn how to translate left to right. So 4 times the number x is added to 12. Okay, the result equals 8. That's basically your equation. So 4x plus 12 equals 8. We'll minus the 12, and we get 4x equals -4. Divide by 4, divide by 4. X equals -1. What number results when 2 times x is added to 7? So 2 times x, 2 times -1 is added to 7. That's -2 plus 7, which equals 5. Choice B. Done. Move on. Number 7. The equation above represents a parabola in the xy plane. Which of the following equivalent forms of the equation displays the x-intercepts of the parabola as constants or coefficients? That's a fancy schmancy way of saying just get this into the double bubble format. Find the zeros, right? So let's factor this. How do we multiply? Well, first thing, I'll put my x's in, right? How do I multiply to get 8? Well, since there's a 6 in the middle, I'm probably going to want to do 4 and 2. When the last coefficient is positive and the middle one is negative, you're going all negatives. Okay? So that is choice D. And if you check it, it works out, right? First is x squared. Let's do outer. So the outer one is -4x. The inner one, I'll use squares, inner, is -2x. And then finally the last is -2 and -4. When you multiply them, you get 8. So this works. You don't have to do this on test day. I'm just showing you that it's the same thing. All right? But on test day, I'd recommend just getting it done and moving on. All right, so 7 is D. Keep going. Let's go find 8. Sorry to make you dizzy there and fly all over. Let's see. 8. In a video game, each player starts the game with K points and loses 2 points each time a task is not completed. If a player who gains no additional points and fails to complete 100 tasks has a score of 200 points, what is the value of K? I feel like I gotta read this one over again because I don't know what the heck I just read. Each player starts the game with K, and so it's K, and loses 2 points each time a task is not completed. So I'll put not completions. That's kind of the formula that you want. If the player who gains no additional points and fails to complete 100 tasks has a score of 200. So at the end of this, he gets a score of 200. And he didn't complete, so now we're just plugging into our formula. He failed to complete 100 tasks. So we don't know what he starts with. It's 2 times how many times he doesn't complete it. That's 100. And our final answer, he has 200 points. So this is just K minus 200 equals 200. We'll add 200, add 200, and you could probably already stop doing the math, but I'll write it out for you. His starting value is 400. So the only thing I did here to figure out my formula, I just literally think it out and go, well, it's some starting number minus 2 times how many times he messes up, and his final score is 200, which they told you. That's it. A worker uses a forklift to move boxes that weigh either 40 pounds or 65 pounds each. Let X be the number of 40-pound boxes. So I see this on test day. I'm putting X is 40-pound boxes. And let's see, and Y is the number of 65-pound boxes. 65-pound box. Okay. The forklift can carry up to either 45 boxes. So carry up to, that's basically saying a max. So that's a max of 45 boxes, right? So how do I write that? Well, X is the 40 pounders, Y is the 65 pounders, and a maximum, so less than or equal to 45, because that's the most they can carry. It says, or a weight of 2,400 pounds. So now, X's are 40 pounds. All right. Well, we've got, how do I want to do that? Oh, I don't know why I had a brain fart. So X's are 40 pounds, so we're going to do a pound equation. 40 pounds, some amount of those boxes, plus 65 pounds, some amount of those boxes, the Y ones, and that's also less than or equal to 2,400. So basically, this is your amount equation right here. This is your amount of things, and this is like your weight equation. So those are the two equations that they're kind of looking for in this problem. So let me just go through and figure out where are we going here. X plus Y. There it is. Oh, it was A. I'm looking right at it. Yeah, X plus Y is less than or equal to 45 because a max of 45. And here's your weight equation right here. The 40-pound boxes, you have some amount of those. The 65-pound boxes, some amount of those. And it's going to be at most 2,400 pounds. That's it. Choice A. Move on. All right, number 10. It's over here. Let me slide this over. Okay. Sorry, one second. Number 10. A function f satisfies f of 2 equals 3, f of 3 equals 5. A function g satisfies g of 3 equals 2 and g of 5 equals 6. What is the value of f of g of 3? My recommendation, and most teachers will tell you this, is do the inside stuff first. So what is g of 3? Well, I told you g of 3 is equal to 2, right? From right there. So now, that answer in there is just 2. So you're really doing f of 2. And what is f of 2? They tell you right there. That's 3. You're done. So just do the inside stuff first and evaluate. And that's it. All right, number 11. This one says, Tony is planning to read a novel. The table above shows information about the novel, Tony's reading speed, and the amount of time he plans to spend reading the novel each day. If Tony reads at the rates given in the table, which of the following is closest to the number of days it would take Tony to read the entire novel? So I'd say it's really important. You got to ask yourself when you get all this information, what the heck am I trying to find? So it's the number of days it takes Tony to read the entire novel. So we got some information here. Let's check it out. I want to know, well, he's planning on, he's going to read 3 hours a day. So this is good. 3 hours a day. Okay. And he reads 250 words a minute. Well, that's useful information. So if he does, let's convert this. 3 hours a day is how many minutes in a day? Wouldn't you just multiply by 60, right? So we'll just times this by 60. And that's going to give us 180 minutes per day. That's what he's going to do. All right, cool. So he does 180 minutes a day, and each one of those minutes he reads 250. So really, it's kind of a proportion you're setting up, but all you got to do is, if he's doing 180 minutes a day, and each one of those minutes he reads 250 words, you just multiply. So I'm not going to do that out. That's why we get the calculator. So you should get 45,000. So this guy reads 45,000 words per day. Okay? So we want to know how many days does it take them. Well, if it's 45,000 words a day, and there's this many words in the novel, you're just going to divide, right? So let's do 3, 4, 9, 1, 6, 8 divided by how many he does in a day. That should give us how many days it takes. So 3, 4, 9, 1, 6, 8 divided by 45,000, 7.759. Hopefully you got that. 7.759 days. What choice is that? Choice B. Closest one. That's it. Move on. All right, number 12. This says on January 1st, 2000, there were 175,000 tons of trash in a landfill that had a capacity of 325,000 tons. Each year since then, the amount of trash in the landfill increases by 7,500 tons. If Y represents the time in years after January 1st, 2000, which of the following inequalities describes a set of years where the landfill is at or above capacity? So first of all, we should just be able to write down or realize that capacity, right, they showed you right here, was 325. So something is going to be greater than or equal to 325,000 tons. Okay, so we start off with 175,000. So 175,000. And what are we adding each year? This is really the only part where you really have to think. You're adding 7,500 every Y years, right? Because Y is years after 2000 and January 1st, 2000. So basically you're trying to figure out when is this, your starting amount, plus the amount that's being added every year, going to exceed or equal 325,000. And that's equation D. And you're done. Pretty much straightforward. You just got to write down an equation and you pick it. You don't even have to solve anything. All right, so number 13 is an interesting question. And it says a researcher conducted a survey to determine whether people in a certain large town prefer watching sports on TV to attending a sporting event. The researcher asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following factors makes it least likely that a reliable conclusion can be drawn about the sports watching preferences of all the people in the town? So this question, I think, is a little, I don't want to say unfair, but the way it phrases it here, which of the following factors makes it least likely? All right, so least likely that a reliable conclusion. So which one of these things, which one of these answers screws up the survey the most? That's basically what they're saying. Least likely that a reliable conclusion can be drawn. So the one you want to pick is D. And the reason for that is that when you're conducting a survey, you want random sampling, right? You want there to be a completely random way of getting your participants. And the problem was, in my opinion, you're doing a survey about having people go watch a sporting event on TV or attending the sporting event, and you're holding it at a place that requires people to go out in public in the first place. They're attending a local restaurant. So your results may be skewed by the very fact that you're holding it at a place where maybe people are more likely to leave and go out. On the flip side, maybe they're more likely to watch the game on the TV there, and that's where all the people who go and watch TV go and watch. So you can kind of skew this any way you want, because where you held the survey kind of screws up your study. So you want something that's completely random. The sample size in this case was 117. That's a decent amount of people. The population size doesn't matter as long as the sample is nice and representative. And the number of people who refuse to respond, I don't know what to say about that. I guess the main thing is that you had enough people in the first place. But really, it's the fact that you're surveying in a public place that's not random. So you have to go with D. All right, number 14. This one says, according to the line of best fit in the scatter plot above, which of the following best approximates the year in which the number of miles traveled by air passengers in country X was estimated to be 550 billion? All right, so it looks like I'm just going to go to the left side of my chart here, and there's 550. And we just got to follow the line. And it looks like it hits right about there. So what are the years here? 90, that's going to be 2005. So maybe 2004, I would say. Let's go down. 2003, that's probably the closer one. Choice C, that's it. All right, number 15. This one says the distance traveled by the Earth in one orbit around the Sun is about 580 million miles each. Earth makes one complete orbit around the Sun in 1 year. Of the following, which is closest to the average speed of the Earth in miles per hour as it orbits the Sun? Okay, so we got Earth makes one complete orbit around the Sun in 1 year. So we're doing 580 million miles, and I would put it over 1 year. Of the following, which is the closest to the average speed of the Earth in miles per hour? Okay, so the issue is that we have miles per year. We just want to know how many hours are in a year. So you could do, let's say 1 year has 365 days, and then 1 day has 24 hours. So that's what you want to set up, a nice little like scientific notation. I forget what you call it, but you just want to make it so the units cancel out, and eventually what you're left with is miles per hour. So let's do that. Let's do, and you're just using your calculator at this point. 580 million, what was that, 7 zeros, divided by, and you can use parentheses on your calculator, 365 times 24, and you should get 66,000. Choice A. And that's it. All I did was this on my calculator. Just to show you so I have the work. Divided by 365 times 24. That's all I did. And I got 66,000. Done. All right, number 16. This one has a chart, results of the bar exam of law school graduates. And it says, the table above summarizes the results of 200 law school graduates who took the bar exam. If one of the surveyed graduates who passed the bar exam is chosen at random, so we're looking at people who passed the bar exam, so that's that column. If one of these people is chosen at random for an interview, what is the probability that the person chosen did not take the review course? Well, here's all the people, right? Did not take the review course, not take. So all we're going to do is, that's 7 people out of a possible 25 to choose from. And that's really all you're going to do. So let's scroll down. 7 out of 25 right there. Choice B. And that's your answer. And you're done. All right, let's look at number, where can I find it? 16. Oh, there it is. 17. All right, cool. Let me just move this over a little bit more. We can make it bigger and do that. Okay, 17. The atomic weight of an unknown element in atomic mass units is approximately 20% less than that of calcium. The atomic weight of calcium is 40. Which of the following best approximates the atomic weight in AMU of the unknown? So all you gotta do is take 40, which is the calcium, and we're gonna multiply it. It's 20% less, but the trick is you just multiply by 0.8. I think I've talked about this trick before. It's very useful. So we're just gonna do 40 times 0.8, you get 32 and you're done. That's the quick way. If it said 30% less, you'd multiply by 0.7. If it was 40% less, 0.6. And you guys see the pattern here? We're just going off 100, right? So 32. You're done. That's the quick way. All right, number 18 says, a survey was taken of the value of homes in a county, and it was found that the mean home value was $165,000 and the median home value is $125,000. Which of the following situations could explain the difference between the mean and the median home values in the county? So let's just go over real quick mean and median, right? If I give you a list of numbers, 1, 3, and 5, the median is 3 because it's in the middle. There's only one number to the left and there's only one number to the right. And it also turns out the average is 3, right? Because these numbers are evenly spaced. right? If you add up 1 plus 3 is 4, 4 plus 5 is 9, and 9 divided by 3, because you have 3 numbers, is 3. So here's a situation where the average and the median are the same. But let's give you another example. 1, 3, and 203. So now the median is still 3, but where's your average? Your average is going to be way swayed over to the right. It's going to be weighted to the right because you got this 203. So that's basically the same thing that's going on in this example here. You've got a median price of 125,000, but the average is being swayed or pushed over, weighted way to the right, higher, because there's probably some houses that are really, really expensive. And that's the example of the list here, where you got 3 numbers, and the median is one thing, but since there's a high-priced house, 203,000 or whatever, the average gets pushed over to the right. So the answer you want here is C. There are a few homes that are valued much more than the rest. All the other choices don't really make sense. The homes have values that are close to each other, not necessarily. There are homes that are valued much less than the rest. Nope. If that was the case, the average would be lower than the median. Many of the homes have values between these values, not necessarily. So C is your best answer. All right, number 19. It says a sociologist chose 300 students at random from each of 2 schools and asked each student how many siblings he or she has. The results are shown on the table below. So we've got Lincoln School, all this adds up to 300, and we got Washington School, and all that should add up to 300. And here's all the siblings, or how many those people have on the left. So what is the question I want to know? What is the median number of siblings for all the students surveyed? So I'm going to start off by asking you a super easy question. How do I find the median? Right? Well, back in 7th grade or 8th grade or even younger, you just get a list of numbers, right? 7, let's say 20. And back in the day, you just go, ba, 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 ba. Oh, it's the one in the middle. Easy, right? But the problem is you've got a ton of numbers. You can't really do that. So we need a little trick. So when you have an odd amount of numbers, say we had 5 numbers here, you just divide, what was I going to say? Since you got 5 numbers and you want to find the one in the middle, you just divide by 2. Sorry, it took me a second. So 5 numbers, divide by 2. That's 2.5. And you just work your way up to the next integer. So the third number is going to be your median, right? 1, 2, 3, there's 5. So what about even numbers? Even numbers, 1, 6, 10, 11, 12, and 100. Well, again, you can do the whole ba, 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 but now we got 2 numbers in the middle. But which 2 numbers are we dealing with to find the median? Well, it's the third and the fourth. So in an even set of numbers, we're just going to divide by 2. So this is 1, 2, 3, 4, 5, 6. 6 numbers. Divide by 2 gives us 3. And it's actually going to be the average of the third and the fourth numbers. Okay? You're going to be doing the average there. So your median is 10.5 in this case. So why did I show you that? Well, it's because you can't list out all the frickin' numbers here. There's just too many of them. It would take too long. But what you can do is use my little trick to say, well, we want to know what? There's 300 students at each school, and we want to know the median for all the students. So that's a total of 600 students. 600 students. So using my trick, what do? Well, we take 600, we divide by 2. That means the median is going to be the average of the 300th and the 301st terms. All right, so let's just see where the 300th term is. Well, 0 siblings, there's 120 here and 140 there, so that's 280. So it's not going to be 0 siblings. We want to figure out where the 300th term is. Well, what do you know? We come over here to 1. That's 80 plus 110 is going to be an additional 190 plus 190. So from these 2 categories alone, you've already covered 470 students. But if you listed all the siblings out, 0, 0, 0, 0, 0, you get up to 280 of those. And then finally, on the 289th number, you'd hit a 1. And how many 1s would you write? Well, you'd write 190. 1, 1, 1, 1. But again, we can't do that, right? So we just want to know where is the 300th and 301st terms going to show up. and that's going to show up when we're writing the ones. Okay, so that's why your answer here, and let me scroll down, that's why your answer here is B. So a little bit of an explanation, but you should know that, just have that little trick and realize you can't list everything out. All right, number 20. This one says, based on the survey data, which of the following most accurately compares the expected total number of students with 4 siblings at the 2 schools? So first of all, if you're here and trying to figure out why you got this wrong, you probably picked choice A. And I'm here to tell you right off the bat that choice A is wrong. So let's go look at both schools and the 4 siblings. How many people had 4 siblings? And I'll show you why choice A is wrong. So you go to your chart here, you look at 4 siblings, and you go, oh, Lincoln School, 10 people had 4 siblings, and Washington School, 10 people had 4 siblings. So it's equal. So then you go back to your answer choice, like, oh, that was easy. The total number of students with 4 is the same at both schools. Wrong. You can't assume that because this is just a small sample. It's a small survey. And both schools have different amounts of people. That's really the key. Actually, that's the real important information there. They have different amounts. So at Lincoln School, 10 out of 300 people, right? Each school had 300 people surveyed, had 4 siblings. So 10 out of 300, which is 1/30. And then Washington School was 10 out of 300. So that ratio, 1/30 of the kids you can expect to have 4 siblings. So now you got to go back. So Lincoln School, and I'll just write it up here. Lincoln School was 2,400 times 1/30. That's why we use that information. So we get rid of that, and that should be 80, right? So now we go to Washington School. I'll write it here, Washington. So Washington School, we've got 3,300 kids times 1/30, and what is that, 110? So now you see that there's a difference in how many people with 4 siblings you would expect, because you're taking 1/30 of the entire school. This is 1/30 of the entire school, okay? So what does that mean? Washington has 30 more people, right? 110 minus 80 is 30. So you can expect 30 more people at Washington. So which one is that one? I think it's C, right? Washington School is 30 more than Lincoln. Choice C. And you're done. That's it.